today we will discuss interval estimation. So we have two types of estimates, point and interval. You can, for example, if population mean is unknown, you can calculate the sample mean to estimate the population mean. The sample mean is just one single number. We don't know how close that sample mean to the true value of the population mean. So we also have interval estimates. So we will discuss the interval estimation about population mean, when sigma known and when sigma unknown. What is sigma? Sigma is the population standard deviation. Sigma is population standard deviation. And determining the sample size for desired margin of error and confidence level, what is the required sample size. And interval estimation, we will also discuss the interval estimation about population proportion. Point estimate is a sample statistic used to estimate a population parameter. If population mean is unknown, you can calculate sample mean to estimate the population mean. Or if you need to estimate the population proportion, you can calculate the sample proportion to estimate the population proportion. But the point estimator cannot be expected to provide the exact value of the population parameter. An interval estimate is often calculated by adding and subtracting a value, which is called the margin of error. So margin of error is the value added and subtracted to the point estimate. Since we cannot, so point estimate is just one single number. You can calculate sample mean to estimate the population mean, but we don't know how close that sample mean is actually to the population mean. That's why we also calculate the interval estimate. This is the general form, point estimate plus minus margin of error. So the purpose of the point interval estimate is to provide information about how close the point estimate is to the value of the population parameter. And the general form of the interval estimate is point estimate plus minus margin of error. The purpose is to provide information, since we cannot expect that, such as if we wish to estimate the population mean, we can calculate sample mean. But we can't expect that sample mean to be exactly equal to the population mean. And different samples will give different results. And we don't know how close the sample mean to the actual value of the population mean, so we also calculate the interval estimate. This is the general form of the interval estimate of a population mean. Point estimate x bar plus minus margin of error. Now how do we calculate the margin of error? Margin of error, which is the value added and subtracted to the point estimate, how do we calculate it? It depends on whether the population standard deviation is known or assumed to be known, or whether sigma, which is population standard deviation, is unknown. So we will discuss two cases here. Sigma known, which is the population standard deviation, and sigma unknown. So we need to calculate this margin of error. We will first discuss the sigma known case. Sigma is the population standard deviation. S is sample standard deviation. S is sample standard deviation, sigma population standard deviation. Sigma is rarely known, so we may obtain good estimate of sigma can be obtained from a historical data. And we refer those cases as the sigma known case. normal curve sampling distribution of x bar, approximated by a normal distribution. Mean is equal to the population mean. And mean is at the center. Now, how do you measure this distance? For example, we would like to obtain 90% confidence interval. This means this middle area will be 0.9. And we would like to obtain two-sided confidence interval. This means this area will be 0.05 and this area will be 0.05. Now, what is this distance from the mean to this point? Z alpha over 2 times sigma x bar. What is Z alpha over 2? Z scores tell us the number of standard deviations that this is away from the mean. This is Z alpha over 2 standard deviations away from the mean. What is the standard deviation of x bar, which is sigma x bar? And what is sigma x bar, which is the standard error, which is equal to sigma over square root of f? If you look at the sampling distribution of x bar, sigma x bar is sigma over square root of f. And how do we find this Z alpha over 2, such as alpha 0.05? If you wish 95% confidence interval, alpha 0.05. What is Z alpha over 2, which is Z.025? What does this mean? This notation, which we will use this a lot in statistical inference, Z, that is 0.05, upper tail area, Z value, the 0.05 upper tail area, 0.025, excuse me, 0.025. So this is Z.025. If that upper tail area is 0.025, how about this area? Since the total area must be 1.975. So now how do we find this Z.025? We come to the chart. Now we know the area, we will find the z-score. Where is that 0.975? So we find the area inside the table, which you see, 0.975. What is that? .96. So 1.9. 1.96. And for example, you calculate the mean, calculate 1 minus alpha % confidence interval. This interval actually doesn't include the true value of the mean, but this one includes. So different samples will give different results. This one actually includes the value of the mean, but this interval doesn't include. So this is how we calculate the confidence interval if sigma known. X bar, which is the sample mean, point estimate of the population mean, X bar, plus minus margin of error. Which is Z alpha over 2 times sigma over square root of, if sigma known, this is how we calculate the margin of error. Z alpha over 2, which is the Z value, providing an area of alpha over 2 into upper tail of the standard normal probability distribution. Sigma is the population standard deviation, n is the sample size. These are some commonly used confidence levels: 90%, 95%, 99%. You can have some other confidence level, for example, 80% confidence level. But these are just some commonly used confidence levels. 90, 95, 99. For example, 90%. Confidence interval. Now this middle area 0.9. What is alpha in this case, which is 1 minus 0.9, 0.1. Two-sided confidence interval, then alpha over 2, 0.1 over 2, which is 0.05. So total area is what? 1. So what is the 0.05? Now what is the total area to the left of this 0.05? 0.9 plus 0.05, 0.95 total area. So that's why it says table lookup value 0.95. So now where is that 0.95? We don't have exactly 0.95, but it is in between these two values. So it is in between 1.64 and 1.65. You can use Excel to find the exact value, or with 3 decimal. If we go to the Excel, with 3 decimal, 1.645. So this is 1.645. This value. This is how we get this one. We are using in an inverse fashion. How can you use this table? Either you know the z-score, you use this table to find the area to the left of that z, such as 1.47. If you have a z-score 1.47, 0.9292 is the area to the left of 1.47. Or you may be given the area, you use it to find the z-score, like we do here. So we showed 95%. How about 99%? What is alpha? 1 minus that, 0.01. So then alpha over to 0.005, 0.005. What is 0.005? Now what is the total area to the left of this C? 0.99 plus 0.005. This means 0.995. Where is that 0.995? Approximately this one, which is 2.57, in between this one, 0.9949 and 0.9954. So it is approximately 2.5 7 and 2.58 in between. If we go to Excel, three decimal 2.576. How do we interpret the confidence interval? For example, you obtain the 90% confidence interval, which is x bar plus minus 1.645 times sigma x bar, which this is sigma over standard error, which is sigma over square root of n. So we say that we are 90% confident that the interval includes the population mean. So this is how we obtain the confidence interval. And it is, for example, you can say 90% confidence interval, or confidence, the question may ask you to obtain 90% confidence interval. Or question may give you the confidence coefficient. For 90% confidence interval, confidence coefficient is 0.9. That is the middle area, 0.9. Such as here, discount sounds as 260 retail outlets throughout the United States. They are evaluating the potential location for a new outlet based upon the mean annual income of the individuals in the marketing area of the new location. Sample size is given. 36 was taken. Sample mean x bar. Population standard deviation is 4,500. And confidence coefficient 0.05. If confidence coefficient of 0.05, then alpha is 1 minus, confidence coefficient 0.95. So alpha is 1 minus 0.95. That is 0.05. Now how do we obtain the confidence interval, which is x bar C alpha over 2 times sigma x bar, which is sigma over square root of n. X bar is 41,100. Alpha over 2, 0.025. This is 1.96 like we discussed here. Margin of error. So what is the lower limit of interval then? Which is x bar minus lower limit of the interval minus the 1,470 630, and the upper limit of interval $42,570. this means we are 95% confident that the interval contains the population mean. So you collected the sample, calculated the sample mean, which is 41,100. But we don't know how close that sample mean, we don't know how close this 41,100 is to the population mean. So we also calculate the confidence interval. How did we calculate the confidence interval? Point estimate plus minus margin of error. Here sigma is given. So then we use that sigma, which is Z alpha over 2 times sigma over square root of n, is the margin of error. So the lower limit of interval is 39,630, upper limit 42,507. So we are 95% confident that the interval contains the population mean. So we can calculate 90%, 95%, 99% confidence interval. Here you see the different confidence levels and commonly used confidence levels and margin of errors for this question. So if we would have calculated 90%, the margin of error would be 1,234, and 99% confidence interval, it will be 1,932. So the question is, so we obtained the 95%. Now we are 95% confident that the interval includes the population mean. But we could have obtained the 99% confidence interval, which now we would be 99%. So this is a 99% confidence interval. Now we are 99% confident that the interval includes the population mean. So can we say that like 99% confidence interval is always better than 90% or 95% confidence interval? That is not true. So we are 99% confidence interval is more reliable than 90% or 95% confidence interval. But what happens if we increase the confidence level? We gain in reliability but lose the accuracy. So 99% confidence interval is a wider margin of error. So your margin of error increases, then you end up with a wider interval. So you lose the accuracy. You gain in reliability but lose the accuracy. So if you increase the confidence level, then yes, you have a more reliable interval, but then less accurate interval. You have a wider margin of error. Your margin of error is now higher. Now, can we obtain such as 99% confidence interval with very small margin of error? Or what needs to change to obtain a 99% confidence interval with a small margin of error? We need to increase the sample size. So this is how we calculate the confidence interval, Z alpha over 2 sigma over square root of n. This is E, margin of error. Now, how can we calculate the required sample size for given margin of error and confidence level? So E equals Z alpha over 2 times sigma over square root of n. We try to leave that n alone, so we can multiply both sides with square root of n. and divide both sides to margin of error. How can we get rid of that square root? We square both sides. So it is z alpha over 2 times sigma e squared. So for desired margin of error and confidence level, this is how you calculate the required sample size. This is the same as either you do it like this or you do it, you first multiply, divided by e, and then square the whole thing. Same thing. So this is how we calculate the necessary sample size. For this compound example, what should the, for 95% confidence interval, margin of error 500 or less, how large a sample size is needed to meet the required precision? %, so alpha 0.05, so then z alpha over 2, 1.96. What was the population standard deviation? 4,500. $500 or less, at most 500. $311.17 approximately. Now, should we round this down to 311, or because it is close to 311, or should we round this up to 312? We should always round it up to 312 because it says 500 or less, so at most 500. If you round it down to 311, the margin of error will be slightly larger than 500, slightly larger. So that's why we round it up. Let's see this using Excel. This is z alpha over 2. So margin of error times sigma 4,500 square root of say 311. As you see now, margin of error is slightly larger than 500. And 311. Larger than 500. Now, what about 312? Less than 500. Since we don't want the margin of error to exceed 500, We round it up to 312. So this is how we calculate the necessary sample size for a desired margin of error and confidence level. We discussed the sigma norm case. Sigma is the population standard deviation. If sigma is unknown, then how can we estimate the sigma? Sigma is the population If sigma is unknown, we use the sample standard deviation to estimate the sigma, sample standard deviation. But in this case, due to the additional variability, now we also have to estimate the sigma. We use a different distribution. Now we use the t distribution instead of the standard normal distribution. T distribution has one parameter, which is the degrees of freedom. Degrees of freedom is the number of independent pieces of information that go into the computation of the standard deviation. We can see the t distribution at the back of the book. T distribution. You see the degrees of freedom, and it gives the upper tail area in upper tail. So the t entries in the table give t values for an area or probability in the upper tail of the t distribution. For example, for 10 degrees of freedom and 0.05 area in upper tail, 10 degrees of freedom, 0.05, 1.8, 1.2. Gives the area in upper tail. And the difference between the t distribution and the standard normal distribution becomes negligible as sample size increases. So with more degrees of freedom, t distribution with more degrees of freedom has less dispersion, which approaches the standard normal distribution. So as the degrees of freedom increases, difference between the t and the standard normal probability distribution becomes smaller and smaller. As the degrees of freedom increases, t distribution approaches the standard normal distribution. Actually, if you look at the infinite degrees of freedom here, this is the t distribution, but you see the standard normal values. This is 0.05, 0.025, 0.01, 0.005. Because the difference between the t and the standard normal distribution becomes negligible as sample size increases. So if sigma is unknown, point estimate is x bar. Now, instead of sigma, we calculate the sample standard deviation to estimate the sigma, and the t. Instead of z alpha over 2, now we use the t alpha over 2 with n minus 1 degrees of freedom. So T alpha over 2 is a T value providing an area of alpha over 2 in the upper tail of a T distribution with n minus 1 degrees of freedom. Df, which is degrees of freedom, it is n minus 1 in this case. How do we calculate the standard deviation? Standard deviation may be given in the problem, or you may be given the data. In that case, how do you calculate the standard deviation? Square root of the variance sum of xi minus x bar squared divided by n minus 1, square root of the variance. In T distribution, the assumption is the population is normally distributed. Reporter for a student newspaper is writing an article on the cost of off-campus housing. Sample of 16 one-bedroom apartments within a half mile of campus resulted in a sample mean 750. Sample standard deviation here is given 55, so we don't know sigma. Sigma is not given. Sample standard deviation is given. Provide a 95% confidence interval. This means alpha 0.05. So how do we obtain it? Which is x bar plus minus s over square root of n. Now here, what is the degrees of freedom? N minus 1, which is n is 16. Alpha 0.05. So what is T? 0.025. Degrees of freedom 15. Degrees of freedom 15. Upper tail 0.025, 2.131. You can look at here. 0.025, 15, 2.131. And x bar 750. This notation, T 0.025, upper tail area 0.025, 15 degrees of freedom. So the lower limit the upper limit is 779.3. So we are 95% confident that the mean rent per month for a population of one-bedroom apartments within a half mile of campuses between 720.7 to 779.3. So in this case, we look at the question. So do we know the population standard deviation? If yes, then we use the standard normal distribution, and of course we use the sigma to calculate the margin of error, and we use the standard normal distribution. So if sigma is unknown, then we have to calculate the standard deviation, sample standard deviation to estimate the sigma, or sample standard deviation may be given in the problem, but sigma here, like in this case, it says a sample of 16 one-bedroom apartments resulted in sample mean and sample standard deviation. This means sigma is unknown. So in that case, we use a sample standard deviation here to estimate sigma, and now we use a t-distribution. Here we only discuss the two cases, but there's also another, like the large sample case. If the sample size is large enough, since the difference between t-distribution and standard normal distribution is negligible, we can still, if we have a large sample size, we can still use the standard normal distribution. But here we only discuss these two cases. So you look at the question, if sigma known, you use standard normal distribution and sigma to calculate the margin of error. If sigma is unknown, then you use the sample standard deviation and the t-distribution to calculate the margin of error. And the interval estimate of a population proportion is very similar to the population mean, which is p bar. What is p bar? Sample proportion plus minus margin of error. And here we will only discuss a normal approximation case. So if n times p larger than equal to 5 and n times 1 minus p larger than equal to 5, we assume that sampling distribution of p bar so can be approximated by a normal distribution. We will only discuss this normal approximation case. In this case, how do we calculate this is the sampling distribution of p bar. Sigma p bar, which is the standard error in this case, is p times 1 minus p over n. Square root of p times 1 minus p over n. But we don't know the p. If we don't know the p, we use p bar to estimate the p, sample proportion, to estimate the p. This is how we calculate the interval estimate of a population proportion. What is p bar? Sample proportion. You know z alpha over 2, which is the z value providing an area of alpha over 2 in the upper tail of the standard normal distribution, square root of sigma p bar, which is square root of p bar plus 1 minus p bar over n, times the sigma p bar, which is the square root of p bar times 1 minus p bar over n. PSI specializes in water polls and surveys designed to keep political office seekers informed of their position in a race. Using phone surveys, PSI interviewers ask registered voters who they would vote for if the election were held that day. So in the current election campaign, PSI has just found that 220 registered voters out of 500 contacted favor a particular candidate. PSI wants to develop a 95% confidence interval estimate. for the proportion of the population of registered voters that favor the candidate. Interval estimate for the proportion. So the P bar is sample proportion 220 out of 500 contacted favor a particular candidate. So 220, which is 0.44. 95% confidence interval, so alpha 0.05. What is Z alpha over 2? 1.96. Margin of error 0.0435, so lower limit of the interval 0.44 minus 0.0435. PSI is 95% confident that the proportion of all voters that favor the candidate is between 0.3965 and 0.4835. Please let me know if you have any questions.